Welcome to the Backyard Professor Math videos. I'm Kerry Schertz, the Backyard Professor. For those of you who aren't aware of it, I'm not a professor at any kind of college. I don't formally teach. My wife called me the Backyard Professor when I kept taking my books with us, like on camping trips and out in nature, because I love to study, I love to read. And I love to study math and science and philosophy and religion and history. And so this idea that she said, you know, you're like the Backyard Professor, and the name just kind of stuck. So that's why my videos are called the Backyard Professor. Let's do some more algebra. There's some properties. There's some properties, and some of these are obvious. I mean, seriously. F equals F. And you go, yeah, well, that's not so profound. M equals M. G equals G. 8 equals 8. 47.2 equals 47.2. This is the reflective property. Very simple, very basic. It just basically says one side of the equation is equal to the other, right? It reflects like a mirror reflects. That's one of the properties in algebra that you want to be familiar with, because it will crop up absolutely all of the loving time. Simple stuff, right? Another property in algebra is called the transitive. Transitive. Ooh, hey, listen to the woodpecker. I'm out here in my backyard, Mother Nature. The transitive property is a really interesting property. It begins to get a little bit more involved. When you see these properties identified in the books, go ahead and play with these. Put some numbers to these so that you can actually see what it shows. And you'll begin to see that literally. Now watch how this works. The transitive property is interesting. It says if A is equal to B and B is equal to C, then it automatically, logically, beautifully, consistently follows that A is equal to C also. If this is equal to this, and this is equal to this, then this is equal to that. That's what's that showing you. And in a way, this can be a little bit confusing. When you put numbers to it, you really see it powerfully. It's beautifully seen in numbers when we put numbers to it. Let's say 3 times 3 equals 9. And let's say that 9 equals 18 divided by 2. Then it automatically follows. Here's one of the things about math that I love, is this logical consistency. Then 3 times 3, this number, that equals 9, is the same as 18 divided by 2. We have two different operations in this, don't we? 3 multiplied by 3. We also have a division, 18 divided by 2, but they are equal. A is equal to B. 3 times 3 is 9. B is equal to C. 9 is equal to 18 divided by 2. So it's perfectly logical that A is equal to C as well. 3 times 3 is 18 divided by 2. Now this doesn't necessarily work with just multiplication and division either. The other nice thing to see about that, this begins to show the interrelationships of numbers back and forth. We can have 3 times 4 equals 12, right? Basic math. 12, we can say, is also equal to 8 plus 4. Therefore, 3 times 4 is equal to 8 plus 4. We have a multiplication on this side. We have an addition on this side, but they're equal. 3 times 4 is 12. 12 equals 8 plus 4. Therefore, 3 times 4 equals 8 plus 4. That's the transitive property of algebra. This will become very important in more complex equations, or when you begin working with 8, 9, and 10 equations, you begin to see how some equations are equal to others. This becomes very important for solving problems. This is a great property in algebra that's used. The commutative property of algebra is really interesting too. It says A plus Q equals Q plus A. It doesn't matter in addition, it doesn't matter what order you add the numbers. If you see a number 2 plus 13, you can add this either direction. You can either add it 13 is 2 or 2 plus 13. They're the same. The commutative works with addition. It also works with multiplication. A times F equals F times A. It doesn't matter how you multiply the two sides, what direction, it's the same thing. For instance, 8 times 4 equals 4 times 8. It wouldn't matter which way you multiplied those together. Now this is interesting because the commutative only works with addition and multiplication. It doesn't work with division and subtraction. And this is one of the tricks you have to see. You have to remember commutative works with addition and multiplication. A minus B does not equal B minus A. And when you put numbers to this, you see this very clearly. Now, it almost seems obvious, but it's important to keep these in mind because as we get deeper into algebra, we're going to manipulate equations all over the place. We're going to take parts of equations and flip them around. We're going to take other parts of equations and put them over there with different parts of equations to try to solve the answers, right? 3 minus 2 is not the same thing as 2 minus 3, is it? In this instance, 3 minus 2 is 1. But in this instance, 2 minus 3 is negative 1, and 1 does not equal negative 1, right? You can see that. Also, 12 divided by 3 does not equal 3 divided by 12. Those two are not the same. You can see that very clearly. 12 over 3 cannot equal 3 over 12. Those two are not the same. So with addition and multiplication, it doesn't matter what order you use. With subtraction and division, it does matter which order you put the numbers. It's very interesting, isn't it? That's fun to see. With the associative property, we begin to see how numbers interact with each other also. Numbers will always interact with each other in one way or another. We need to understand how the properties work to their interacting. A plus B plus C is the same thing as A plus B plus C. It doesn't matter who they associate with. In this instance, B and C are buddies. They're together in the parenthesis while A is out here. In this one, the A and the B are friends, and the C is left out here. But they're both equal. And you can see this when you put it to numbers. Let's do 1 plus 2 plus 3 equals 1 plus 2 plus 3. 1 plus 5 is 6, and 3 plus 3 is also 6. So this is how the associative works with the addition. It's interesting that the associative property also works with multiplication. If you have 1 times 2 times 3, and we associate the 2 and the 3, this is the same as 1 times 2 together times 3. And you can see what that says. It's 1 times 6 is the same thing as 2 times 3. 1 times 6 is the same thing as 2 times 3. Just like the commutative property, this works with addition and multiplication, but the associative and the commutative do not work with the division and the subtraction. They are not the kind of properties that work with the associative and commutative. Now, the distributive property is probably the single most used property. This one we will use the further we get into math, absolutely all the time. It is very important to understand. This is a good one. A times B plus C. What we do here is anything in a grouping bracket, a parenthesis, a brace, a bracket, is together as a group. The term immediately next to the parenthesis is telling us that this A is going to be multiplied with this B, and this A is also going to be multiplied with this C. And so, AB, this equals AB plus AC, because there's a plus sign in here. If we had this as A times B minus C, this would equal AB minus AC. You use whatever operation plus or minus is being used, but you distribute the outside term into each of the terms inside the parenthesis to get your answer. This one we will use over and over and over and over again. This is one of the most important ones. It comes real big in when we start factoring, as you'll see. So understand the various different properties of the way algebra numbers work together gives us the basis to not only think clearly, but to find the relationships between the numbers that help us solve the problems. This is a very important concept. Well, let me show you an example. 2, if we had 2 and we had 3 plus 1 here, this would go to 2 times 3. You distribute this 2 to each one of the terms in the parenthesis, so that's going to be 6. And then we go 2 times 1, which is 2, and that equals 8. And that is the answer. If you add the inside terms, 3 and 1, you can see that that's 4. and 2 times 4 is 8. So that's how some of the different properties in algebra show us how the numbers work and coordinate together, and it's beautifully, consistently, and logically applied all the way through the math. So once you get this foundation, you can apply this in all the math you have. It doesn't matter if it's in geometry, trigonometry, pre-calculus, calculus, advanced calculus, it really doesn't matter. These properties hold consistently all the way through the mathematics. And that is seriously to our advantage. The additive property is one of the simpler ones, but it is very important to understand. A plus 0 equals A. If I wouldn't let my fat finger wreck that 0. A plus 0 is A. F plus 0 is F. T plus 0 is T. 9 plus 0 is 9. 38.49 plus 0 is 38.49. This basically tells you that any number or any variable, if we don't yet understand the value of that variable, anything added to 0 is just that number. Now this is the additive. The multiplicative, when you go to multiply, it's the number 1 that's important. C times 1 is going to be C. D times 1 is going to be D. X times 1 is going to be X. 8 times 1 is 8. 46 times 1 is 46. No matter what number, no matter what variable, ms squared times 1 is going to equal ms squared. 3/9, which is 1/3, times 1 is going to equal 3/9. 47/58 times 1 is going to equal 47/58. It doesn't matter whether it's fractions, decimals, variables. In multiplication, any number times 1 is just that number. Whereas with addition, any number added with 0 is just that number. Now see, these are a few of the basic laws in algebra that build our foundation for being able to work all the way through all of the maths. It's irrelevant if you're working with geometry or trigonometry or calculus, it doesn't matter what. If you run across a number that's multiplied by 1, you know it's automatically going to be that number. Isn't that cool? That is very interesting, isn't it? It's the same thing with any number divided by 1. Let me show you this. It's important to understand there are a couple of exceptions to this that I will get to eventually as I have time. There's only so much time I have to show you this stuff, right? 4 divided by 1 is just 4, right? X cubed divided by 1 is simply x cubed, right? So this is the idea. 36,373,414 divided by 1 is 36,373,414. It's just that number. And if it's multiplied by 1, it's still just that number. Now, if we add 1, you can see the difference there, huh? That then becomes 36,373,415. Or if you subtract 1, then this goes to 36,373,413. So adding and subtracting make a difference, whereas multiplying and dividing by 1 doesn't. Isn't that interesting how the numbers behave in this manner? I really think that's one of the fascinating parts of mathematics. And you begin to play with these things, and you begin to see patterns that is really cool. It's really quite fun to do. Play with it. This is math. We're supposed to explore, to play with it, to learn, to develop our ability to see new patterns that we have never seen before. This is the idea. This is how you learn, is by playing with the mathematics. Absolutely. Now, real briefly, let me show you the natural numbers. The natural numbers are simply the numbers we count with. 1, 2, 3, 4, 5, 6, 7. This lemniscate here, the dot, 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 and then the lemniscate, the lazy 8 on its side, just means it goes forever that away to the right. Those are the natural numbers. It's what we count with. Rocks. I have 1 rock. I pick up another rock. I have 2 rocks, etc. You just count everything you count with, right? The whole numbers are all of the natural numbers plus 0. Now 0, we haven't always had 0. Boy, that's a fascinating history. 0, the nothing that is. There are some really wicked paradoxes with 0 that we will understand in math as I go forward with the math. I'll show you some really interesting ideas and properties of 0. It's very interesting. Especially when I get to fractions. And I will be getting to fractions. I'm going to take your fear from fractions completely away from you. They're not difficult at all. There's just a couple of simple things you need to understand, and it's a piece of cake. I promise. So we have the natural numbers, the ones we count with. The whole numbers, you simply include 0. The integers include the natural numbers, 0, and the negative numbers, all the way out to infinity. And this, you can see, is the number line. You draw a line, you start at 0, you go to 1, you go to 2, you go to 3, you put the arrow to show it goes forever out that way, you go to -1, you go to -2, you go to -3, and the arrow shows that it goes all the way out that way. This is simply the number line. So the natural numbers are the ones we count with, starting with 1. The whole numbers, we just include 0. And the integers, we include the negative numbers. Now, negative numbers, you notice the symmetry here. Negative numbers are very necessary, even though numbers themselves don't actually exist in the world. You can't point to something and say, ah, there's the number 1, like you can to a tree. There is a 1-ness, and there is a 2-ness, and there is a 3-ness, and a 54-ness, and so on and so forth. But you can't point out in the natural world to the numbers. You can't with the negative numbers either. So think of negative numbers as debt. You borrow $10 from your dad. You are $10 in the negative. You have to pay that back. You're $10 poorer, right? Until you pay it back. You got to go get a job, make some money, and pay him back, right? So the negative numbers are very interesting. Or you can think of below 0 weather, you know. When it gets 10 below 0, you know it's starting to get cold as opposed to 55 degrees above 0. Everything to the right of 0 is positive. My marker will work. Everything to the left of 0 is negative. 0 is called the origin, right? We just start at 0, and every time we go to the right, we always get larger numbers. Every time we go to the left, we get the smaller numbers. That's just simply how the numbers work. The consistency, the beauty of mathematics here is, we know that the further right you go, the bigger the number is. This will help us when we start talking about positive and negative numbers and how to add, subtract, multiply, and divide them also. 3 is always going to be larger than 1. Why? Because on the number line, 3 will always be to the right of 1. Anything going to the right gets larger. Anything going to the left gets smaller. And it doesn't matter where on the number line you start, that always consistently holds true. That's why when we draw number lines, we can see the evidence for ourselves. 2 is always going to be larger than negative 3 here. Why? Because 2 is this far to the right of negative 3. We know 2 will always be larger than negative 3. In geometry, in trigonometry, in calculus, in algebra, in simple addition, subtraction, multiplication, and division, we know this will always hold. And that is the beauty, that's part of the fun of exploring mathematics, is to see the relationships of big and small, bigger and smaller. You're simply going right or left on the number line. Isn't that cool? I think that's cool. It's a very helpful principle to help us visualize what we're doing when we solve equations. So anyway, this is enough math for this video. Thanks for watching my Backyard Professor Math videos. Remember 2 things: happy calculating and have a great life. Oh, and a third thing. I'll see you in the next video.